So get out quiz number 3. You'll notice there's a type at 5. We're in unit 7. Hey, not that it matters, but energy. Your test is going to be next class. Sadly, I'm not going to be easy to find after school most days. You can try me a little bit Friday after school for a few minutes, but I'm not here for very long. And Monday after school, I have to leave right away. So check with your friends, check with your neighbors, help each other. Here we go. My favorite student, good old Anne. How much work would it take to stop a 950 kilogram vehicle traveling at 45 meters per second? Well, of course, the first thing I think is work is force times distance, but I don't see a force or a distance here. So I'm going to think it's the change in potential plus the change in kinetic, because there isn't a graph. This is the work energy theorem. It doesn't look like there's any kind of a change in height. I don't see a hill mentioned in the question. What's change in anything? Change in anything is going to be KE final minus KE initial. And I think the final is 0. So how much work? It's going to be negative a half mv initial squared. Negative 0.5 times 950 times, how fast are we going? Ooh, 45 squared. That's pretty fast. It's going to take that much. Negative 9, I'm going to write it as 962 000 joules. If you wrote the whole thing, that's fine. Really, 2 sig figs. I should go to 2 sig figs. If you didn't put the negative, if you wrote the word lost, I'm okay with that. And I'll be honest, if you didn't put the negative, because I asked how much work would it take to stop, you could say, Mr. Duke, it would take 962,000 joules of work to bring it to a stop, and that kind of implies that we're losing energy. So if you don't have the negative there, I'm not going to freak out. B, force. Well, force is work over distance, because work is force times distance. How much work? 961,875 divided by 150. I've chucked the negative. The negative here would be telling me that the force is in the opposite direction of motion. 6412.5. I'm going to write 6,400 newtons. I'll go to 2 sig figs because that's really what I should be doing in this question. What's the minimum coefficient of friction? Well, friction equals mu times the normal force. I guess that means that mu is going to be friction divided by the normal force. I know some of you want me to say, what's this question asking me to find? What's mu? I don't know. What's mu with you, Mr. Duke? Oh, boy. What's the force of friction? Well, the force of friction is that there, because it's friction that does the work to bring the car to a stop. So it's going to be, I'll put the full value in, 6412.5, 6412.5. I don't know the normal force. You know, if I do a quick free body diagram, though, I'm pretty sure I have gravity down, I have normal force up. If the car is moving to the right, that means that friction is acting to the left. I don't know the normal force. Oh, but look. I know the force the same size as the normal force. I think mg is going to go here. What was the mass? I think 950 times 9.8 is going to go here, divided by 950 times 9.8. I'm going to ignore the negative on my calculator. I get a coefficient of friction of 0.689. 0.69, I'd take that as well. Units, none. Number 2, I stole this right from our lesson, RCMP investigation. Now they want me to find speed. The fact that they said speed and not velocity is a hint I should use a scalar approach. I see coefficient of friction. I see skid marks. By the way, you could probably find this using forces, using winner minus loser, finding the acceleration and finding V final. But I think I can get there in one fell swoop by going work is change in potential plus change in kinetic. I don't think there's any change in height. So this is going to end up being KE final minus KE initial. And I'm pretty sure final in any car accident is 0. So we're going to get this, negative a half m V initial squared. Now that I've come this far, I'm going to ignore the negative. I'm going to chuck the negative out. On the left-hand side, work, I think the work is going to be the force of friction times distance. I think it's going to be mu times the normal force times distance. I don't know the normal force. Oh, but look. I know another force the same size as the normal force. I think I can say mu mg d equals a half m v initial squared. They didn't give me the mass, but you know what? They didn't need to. Thankfully, they cancel because there is an m in everything. I want to find the initial speed. I think I'm going to times by 2 and then square root. I think the initial speed is going to be the square root of 2, 0.55, 9.8, 52. 2 times 0.55 times 9.8 times 52, square root, 23.7 meters per second. Probably should go to 2 sig figs, so if you said 24 meters per second, I'd take that. I'll go 23.7 meters per second. Just for giggles, times by 3.6, 85 kilometers per hour. They're going to get charged, probably. Okay. Why did I say minimum speed? Because they might have slowed down already. Now, this is worth 3 marks. If you got the right answer, 3 out of 3. Otherwise, 1, 2, 3, 4, 5. Yeah, I'd probably go something like this. I'd give you 1 whole mark if I saw the work energy theorem. Let's change colors, Mr. Dewick. Let's go with blue. 1 whole mark for that. Half mark if you substituted in that work was force times distance, the force of friction times distance. I would give you 1 whole mark if somewhere I saw V equals the square root of 2 mu g d, whether it's in rough form like I have or on a completely separate line. And then I would give you a half mark for the answer, and I think that adds to 3 whole marks. Child on a water slide. Hey, there's a change in height, there's a change in speed, there's a curvy path. They want me to find how fast if we ignore friction. This is a job for conservation of energy. I'm going to start out going KE initial plus PE initial equals KE final plus PE final. Are any of these 0? This time my initial is not 0. I'm moving, so I can't cross that out. Initial height isn't 0. You know what? The only thing that's 0 is that there. I'm going to get a half m v initial squared plus m g h initial equals a half m v final squared. Now, they did in this question give me the mass. It is 45, but it turns out I do have an m in everything. I can go, yay! And if I want to get the VF by itself, I guess I could divide by a half and then square root. Let me do that on a completely separate line. So I'm going to bring that back. I would say that VF is going to be 0.5 VI squared plus GHI divide by a half square root, which is going to be 0.5. What was VI? 8.3 squared plus 9.8. 21 was the height. Divide that whole thing by 0.5. It is a fraction. I'll put the top in brackets. It's going to be bracket 0.5 times 8.3 squared plus 9.8 times 21. Close off the top. Divided by 0.5 square root. And I get, ooh, nice, 21.9. By the way, that's ignoring friction. You're going pretty fast. You're going almost 80 kilometers per hour. I don't know how realistic that is, but I was making up numbers. 21.9 meters per second. Well, you know what? That would be realistic if there was no friction on water slides. Now, there is a lot of friction on water slides because you're running into the water itself. It slows you down. If you got that, 4 out of 4. Otherwise, I would go something like 1 mark for that, 1 mark for that, 1 mark for that, and 1 mark for the answer. Suppose the child is only traveling 16 meters per second at the bottom. Only 16 times 3.6. Suppose you're only doing about 60 kilometers per hour at the bottom. Still pretty fast. Okay, how much energy was transformed into heat? KE initial plus PE initial equals KE final plus PE final plus heat. That's still going to be 0. I want to get the heat by itself. How? I'm going to minus the KE final over. So the KE initial is going to drop down like a domino. PE initial is going to drop down minus KE final. That equals the heat. The heat is going to be a half mv initial squared plus mgh initial minus a half mv final squared. Do the m's cancel here? Well, there's an m in there, there's an m in there, there's an m in there, there's no m in heat. So this time I can't cancel the mass. Heat is going to be 0.5. What was the mass? 45? 45. Initial speed was 8.3. 8.3 squared plus 45 times 9.8 times 21 minus 0.5 times 45 times 16 squared. All right, sorry, I was just double checking to make sure I hadn't made a typo earlier. Half mv squared plus a half m, sorry, not a half, plus 45 plus mgh minus a half mv squared. 5,051 joules. I'm going to go 5,050. If you got that right, 4 out of 4. Otherwise, I would probably go 1 mark for that, 1 mark for that, 1 mark for that, and 1 mark for the answer. Oh, roller coasters. Gotta pause the video for a second, though. So keep going. Roller coasters. Oh, good stuff. Starts from a standstill. Okay, that's a fancy word for from rest. Top of a 90-meter hill. Passengers, the mass is 400 kilograms. What's its velocity at the bottom of the hill? Hey, there's a change in height. There's a change in speed. There's a yucky, curvy path. This is a job for conservation of energy. Although technically, I'm not going to be finding its velocity. Technically, I'm going to be finding its speed. I'll change that for next year. Anyways, KE initial plus PE initial equals KE final plus PE final. I don't think it wants me to include heat. Starting out at rest, I'm ending up on the ground. I end up with mgh initial equals a half mv final squared. I have an m in everything, so I can cancel the m's. You don't have to, by the way. If you put the 400s in both spots, they'll just take care of themselves and you'll still get the same answer. They want me to find speed. You know what? I think I'm going to end up with v final being 2gh initial square root, or instead of timesing by 2, you could divide by 1/2, by 0.5 right there. So it's going to be the square root of 2, 9.8, 90, 2 times 9.8 times 90, square root, 42 meters per second. How fast will the coaster, for 2 marks, I would go like this. 1 mark if I saw that, sorry, not 1 mark, Mr. Duke. For 2 marks, half mark if I saw that, half mark if I saw that, half mark if I saw that, and a half mark for the answer. But as usual, if you got the right answer, 2 out of 2. Top of the next hill is 50 meters high. How fast will the coaster be traveling at the top of the next hill? So now I'm going to let this be initial and this be final. I'm going to ignore location A. You could let location A be initial, and it's actually less work to do the question that way. The risk you're taking is if you got this answer wrong, you're guaranteed to get answer B wrong. So I'm going to start with the information that they gave me, which looks like this. KE initial, PE initial equals KE final plus PE final. The only thing that's 0 is my KE initial. They want me to find how fast the coaster is going to be traveling, so I'm going to get this. mgh initial equals a half mv final squared plus mgh final. And I'm going to end up minusing that to that side. Also, there is an m in everything, so I can go like that. I'm going to get GH initial minus GH final equals 0.5 or a half V final squared. And I want to get the V final by itself. How? I think I'm going to divide by 0.5, square root. It's going to be GH initial minus GH final, all divided by 0.5, square root. It's going to be the square root of 9.8 times 90 minus 9.8 times 50, all over 0.5, and then square root of that. 9.0, fraction, more than one thing on the top brackets. 9.8 times 90 minus 9.8 times 50 divided by 0.5, square root 28 meters per second. If you got that, 3 out of 3. Otherwise, 1, 2, 3, 4. Yeah, I'd probably go something like this. I'd probably give you a half mark for that, a half mark for that, a half mark for that. I'd give you 1 whole mark if I saw that you'd be able to get the V by itself. That's 2.5, and then a half mark for the answer. Nearly there. I like number 5, I like number 5, I like number 5. Number 5 is a nice question. Also, I used to teach archery at summer camp, so I've shot a lot of bows and arrows in my time. A full draw is the maximum distance that an archer can pull back a bow using the recurve bow shown below. A particular archer requires an average force of 130 newtons to pull it 70 centimeters. How much work is done pulling the arrow back? Well, work. First thing I might try is force times distance. Hey, they gave me an average force, 100, and they gave me a distance, not 70, 0.7. How much work? 130 times 0.7, 91 joules of work. 1 mark. How much potential energy is stored in the bow? 91 joules. Not potential energy, MGH. They didn't give me a height. This is stored in the bow. I've done 91. The archer has done 91 joules of work on the bow. That's how much energy the archer has lost. The archer has given that energy to the bow. The bow is storing that energy, ready to pass it on. If the arrow has a mass of 18.6 grams, what's the maximum speed? Assuming that all of the potential energy, here's what we're saying, all of the potential energy turns into kinetic energy. You could do this with the law of conservation of energy, G, because you could say the initial kinetic is 0 and the final potential will be 0. But I'm saying all of the potential, that 91 joules of energy, is going to turn into a half mv squared. And we're going to get the v by itself. V is going to be 2 times 91 divided by the mass, divided by 18.6, which is 0.0186. Now that's v squared, square root. How fast will this leave? 2 times 91 divided by 0.0186, square root. This is Holland. 98.9 meters per second. So you got that 2 out of 2. Otherwise, I would give you a half mark for seeing that. A half mark if somewhere you said that a half mv squared equaled 91. Half mark for getting the v by itself. And then a half mark for the answer. Bonus. Oh, cool. If the arrow only leaves the bow with a speed of 54 meters per second, how much energy was lost to heat? Now we're going to use conservation of energy, but it's going to be KE initial plus PE initial equals KE final plus PE final plus heat. The only one of these that's 0 is my final potential, because when you let go of the string, all of the bow's stored energy gets passed either to the arrow or gets turned into heat. I want to get the heat by itself. I think I'll do that by minusing that to that side. Heat is going to be a half m. Oh, wait a minute. KE initial is also 0. You're starting out at rest, aren't you? So that was silly of me. So heat is going to be the initial potential energy, 91, not MGH, because that's not what this energy is stored as, not gravity energy. Minus a half v final squared. It's going to be 91 minus 0.5, 0.0186, 54 squared. It's going to be 91 minus 0.5 times 0.0186 times 54 squared. 63.9 joules. Or, for those of you who are interested, if you wanted to calculate the efficiency, that's how much energy we got lost to heat. So 91 minus that, that's how much energy got changed into kinetic. And if I divide that by how much we stored, how much work we did, times 100, this bow is about just shy of 30% efficient. It's probably low. I think a bow is more efficient than that, but I was just making up numbers. Anyways, bonus question, all or nothing. All or nothing. Can you give yourself a lovely score, please, out of 23? Mr. Dueck, what? Can we hang on to these to study from? Yes, you can hang on to these to study from, since I don't see you between now and the test. In fact, you know what? I'm not going to collect this quiz. If you did it, good, you'll do better on the test. Some of these questions will show up verbatim on the test, exactly as is, with different numbers. If you didn't do it, well, you missed out on a chance to work through some questions. Your homework for the remainder of class work on the unit review, work on any other missing work energy assignments. Here's what I don't want to see. I don't want to see you on your phones playing video games unless you're totally caught up, unless you're totally done, and not that many of you qualify. Okay?